So I've been doing chemistry as a hobby for a little over 2 years now, and one day after taking an inventory of all the chemicals I had, I thought it would be interesting to see how many elements or representatives of each element that I had for the periodic table. So what I came up with was 40 different elements and compounds in my collection. So I'll briefly go through each one individually and talk about it just a little, maybe mention how I obtained it. So let's get going. So the first element from the periodic table that I have a representative of is element number 3, lithium. Now, obviously it's easy enough to find elements that have or compounds that have hydrogen in them, but that wouldn't be very interesting, and I really wanted the dominant element by weight to be the one that I'm representing in my collection. So I skipped hydrogen and I skipped helium, and here's lithium. Now what this is lithium hydroxide. And it's a white powder, has an atomic mass of 6.94. Now I made this in the lab by using the lithium from these Energizer lithium batteries. So if you take the battery apart, react the lithium foil carefully with water, you can then produce lithium oxide. So second up is element number 5, which skipped over beryllium, went to boron, and this is a compound, boric acid, H3BO3. It's also a white powder. And I obtained this by recrystallizing the boric acid from this over-the-counter product. And it says it's 99% boric acid. Next on the list is element number 6, which is carbon. And this was not very difficult to obtain. Rather than just go for charcoal, which is not pure carbon, I decided to make my own. I could have bought some activated carbon, but I decided to make some, and I made it from this starch that you can buy at the supermarket. If you take this is potato starch, corn starch will work as well. If you take it and you simply apply the proper amount of heat, it will decompose into just carbon. If you get it too hot, your carbon will start to burn, and then you won't have it. So if you're careful, you can end up with some nice pure carbon. Next is element number 7, nitrogen. Now to represent nitrogen, I have chosen ammonium nitrate. It contains a lot of nitrogen. NH4NO3 is the formula. It has a molecular weight of nitrogen has an atomic weight of 14.007. And I got that ammonium nitrate from this product that you can buy over the counter. It's Top Care ice compress. Inside you'll find a couple of packs of ammonium nitrate and some water to mix it with. Next up is element number 8, oxygen. has an atomic weight of about 16. And to represent oxygen, I have these blue crystals of copper sulfate. And if you look at, this is the pentahydrate version of copper sulfate. If you look at the formula, CuSO4, then the 5H2O, and you'll find that oxygen is, by weight, the dominant element in this compound. It's also very pretty. Okay, after oxygen, I went to element number 11, which is back on this side of the table. And this is sodium, atomic weight 22.989. And as representative of sodium, I have a compound called sodium sulfate. And let's see, where did I get that? I think I made it in the lab, but don't really remember doing it. I have a little bit more here in this jar. It's pretty easy to make. So after sodium, I have magnesium, element number 12, atomic weight 24.3. And representing magnesium, in a compound form, I have magnesium sulfate, heptahydrate, which is actually just Epsom salt, which is easy to buy. And after magnesium, moving across the table, we come to number 13, aluminum. Now this is the element aluminum, atomic weight 26.98. And what I have here is just little pieces of aluminum wire that I cut up. And I obtained this just from some aluminum wire that I had purchased to use in experiments. Sometimes it's better than aluminum foil, or aluminium if you prefer. Next up, element number 14, which is silicon. This is another compound representing silicon. This is silicon dioxide, very common on Earth, which is mainly just sand. Now this is nice and white, very powdered, and I made that from some milky quartz rocks that I had found. I simply ground them up and then soaked them in hydrochloric acid to get rid of the iron stains. So that's element 14. Number 15 is phosphorus. And this one was one I only had one choice after looking at all the chemicals I had in my lab. I don't have any elemental phosphorus, but I did have one compound, trisodium phosphate. Now, trisodium phosphate I purchased as a cleaning agent. It's not pure trisodium phosphate, but it's 75 to 80% as far as my research could determine. And so that's the representative that I'm using for phosphorus. Moving on to element 16, and I do have the element this time. It's sulfur, and its atomic weight is 32. And I just have it in a powder form. And I got this from a garden center that was selling sulfur as a soil acidifier, and I have a very large jar of it. Probably more than I'll ever use. Next up, number 17. After sulfur comes chlorine. Well, obviously I don't have a chlorine gas here. This is another compound. This is copper chloride, CuCl2, and I did make that here in the lab. And I have a larger jar here that I taken it. Now, copper chloride is interesting that it often will change colors from a light blue to a green, depending on its hydration and things like that. So the one I have in my little vial here is more green, and my stock solution, copper chloride dihydrate, is more of a bluish color. Moving on, after chlorine, obviously I skipped argon. That wouldn't be very interesting. I went on to number 19, potassium. And potassium is atomic weight of 39.09. And this compound that contains potassium is potassium sulfate, which I made from extracts from wood ash that I have made videos of me doing that. And it makes really nice crystals that almost looks like ice. And the formula is K2SO4. So moving on to element number 20, which is calcium, atomic weight 40. I have another compound representing calcium, which is calcium carbonate. And this I also made by reacting calcium chloride and sodium carbonate. It makes a nice precipitate. CaCO3 is the formula. And after 21, I skip, after 20, I skip scandium, titanium, and vanadium, and I come to number 20. Well, I skip chromium also. I come to number 25, manganese. Now this compound is manganese dioxide. I did not make this, I purchased it, and this is the bottle that I got it in. That's MnO2. After that is element 26, iron. Now this is an iron compound. This is not, it would have been easy to just put elemental iron in there. But this is an iron compound. It's interesting. It's magnetite. It's Fe3O4, a form of iron oxide. And I got this one time in Colorado when I was panning for gold. This is the black sand that you find at the bottom of your gold pan, which is usually easy to get, but I didn't get any gold. But this is magnetic, so it reacts to a magnet. Actually, I can demonstrate that. I have one right here. Magnetite. So after element 26 is element 27, cobalt, and atomic mass 58.9. This is another compound representing cobalt. It's a beautiful purple color. It's cobalt chloride, and this is what it looks like in the anhydrous state. And COCl2 is the formula. And I did purchase this as well. This is a purchased chemical. So after cobalt is nickel, element 28, atomic mass 58.69. This contains nickel sulfate, hexahydrate, NiSO4 6H2O. I did make this in the lab, made it out of nickel welding rods. And I don't have a video of that, but it makes beautiful greenish blue-green crystals. It's highly toxic though, so handle it with care. The next element is copper, number 29, and this is in elemental form, but as you can see, it's a powder. And hopefully in an upcoming video, I will be showing how I made the copper powder. Atomic weight 63.5. So after copper is element 30, zinc, atomic mass 65.4. This is just zinc shot, little chunks of zinc metal. This was purchased as a laboratory chemical. So after zinc, I skipped gallium, I skipped all the way over to element 35, bromine. So bromine is 79.9 atomic weight. And the representative compound here is sodium bromide, NaBr. And I purchased this as a, I believe it was a either swimming pool chemical or a hot tub chemical. I don't remember which. I have a larger jar of it here. So I remember it was rather expensive, so I didn't buy too much. So after bromine, I skip down to element 38, strontium. And this is a compound of strontium, which is strontium nitrate, SrNO32, and then 4H2O. So it's hydrated. And I obtained this from a road flare, which might be another video I do in the future as to how I obtained that. Moving on, I skip up to element 47, silver. And silver has an atomic mass of 107.86. And this is a compound of silver. This is silver nitrate. I made that by dissolving elemental silver in nitric acid. Moving on up to element 50, I have tin. This is the element tin, and little tin shot, and its atomic mass is 118.7. I did purchase that. Here's my larger supply, I had about a pound of it. So after tin, I have antimony, and this is also the element, antimony, and I did purchase that. Here's my bulk supply, 1 pound, 99.8% pure. I haven't found a good use for it yet. Moving on to element 53, iodine, atomic weight 126.9. Now, what you see here is a compound of iodine. It's a white powder. This is potassium iodide, which I made. I do have some elemental iodine, and that looks like this. And I did have it in a little vial like this with a cork, and sealed with hot melt glue, just like all the others have been. But I found after a few weeks, the iodine was actually migrating up through the cork and sort of reacting with the glue as well, and it was kind of escaping, and leaving an iodine stain in my container. So I had to go and make an iodine compound, and then I eliminated that problem. So it's okay in this jar, but the vial with the cork wasn't working. So after iodine, I move up to element 56, barium, atomic weight 137.3. Here's a nice little white crystalline powder. This is barium chloride, BaCl2, 2H2O, the dihydrate. I did purchase that. It's in this larger jar here of barium chloride. And I use this, I purchased this because I wanted to test for sulfate salt in my wood chemistry experiments, wood ash chemistry experiments. Moving on from 56 all the way up to 79. This is gold. Atomic weight 196.96. Now what I have in here is not pure gold, it is gold-plated wires. So you certainly see what gold looks like, but it's I didn't have a gold coin or anything that would fit into that vial. I didn't want to sacrifice it for that anyway, so that's my representative of element 79 gold. And moving up to element 82, lead, atomic mass 207.2. You can probably guess what that is. Lead shot, just like you'd find in a shotgun shell. Lead pellets. Easy enough to obtain. And the last but not least, element 83, bismuth. This yellow powder is a compound of bismuth called bismuth 3 oxide, Bi2O3. And I did make this from Pepto-Bismol. That's the one you buy at the pharmacy to treat your antacid. And I did have a video on how I made this. Oh, a few things I forgot to show you. My larger sample of silver nitrate. Not much to see. Here's a jar of beautiful copper sulfate crystals that I forgot to show. My calcium carbonate that I made, a larger volume of it. Here's the nickel sulfate. It's in a very saturated solution here. The mini crystals you can see on the bottom. I keep that tightly sealed. Magnesium sulfate, simply Epsom salt. And the potassium sulfate crystals that I made from the wood ash. You can also buy potassium sulfate as garden fertilizer, and you can recrystallize it and get these crystals. They look just the same. So that's about it for this video, and that's the entirety of my element and element compound collection to date. And I probably may not add any more. These were the easy ones. It would be possible to get a few more, of course, but I have a nice round number of 40, and I'll probably just stop my collection there. So thanks for watching.